As it turned out, it's actually a man-made substance called a chlorofluorocarbon that has been introduced into the environment, and these chlorofluorocarbons have, if you do the modeling and do the chemistry, they can account for the decrease in the ozone concentration. So what are they and where did they come from? A chlorofluorocarbon is a hydrocarbon, which is an organic molecule made of carbon and hydrogen that also contains chlorine and fluorine. Sometimes they're called CFCs for short, chlorofluorocarbons. The most common the CFCs, I should say, do not occur naturally. These types of compounds are all completely synthetic. That is, they've been made in the chemical laboratory and on an industrial scale. And so it's called a synthetic material, something that's a man-made material, chemical that is not found in nature. And the two most common CFCs that have been introduced into the environment are Freon 11 and Freon 12. Freon is a trade name of the company DuPont. DuPont is the company that made them first, and so they call them Freon. The general, so that's the trade name. Freon. It's kind of like Teflon. Teflon is a trade name of DuPont also, and that's just a polymer that's a fluorocarbon, and that's the stuff that they coat pans with that allows food not to stick to pans. But anyway, Freon 11 and Freon 12. The general common name for Freon 11 is CFC 11 or CFC 12. Very simple molecules. The Freon 11 is just CCl3F, and the Freon 12 is just CCl2F2. Okay? And if you do the Lewis structure, the carbon is the central atom, and these halogens, chlorine and fluorine, are in the group on the periodic table that we call halogens. The halogens are all terminal to the carbon. So CFC11 is just simply carbon with 4 bonds, and on one bond is fluorine, and on the other 3 bonds, covalent bonds, is chlorine. And then all of these halogens or chlorines and fluorines have 8 valence electrons. It's a very, very stable molecule. This one's similar, 4 bonds on the carbon, only 2 of them are fluorine and 2 of them are carbon. Okay, so this is what the molecule looks like. The molecules look like. As it turns out, these molecules are very, very stable. These carbon-chlorine bonds are very strong and stable. They do not break easily. These molecules are so stable. All of the octets are filled. It's a very stable molecule. It's not going to react with anything else. So that is a great unique property. And because of the properties of these molecules, the fact that they're stable and also that they have a relatively low boiling point, they became commercially very, very important. So the unique properties of the CFCs led to major economic growth. So they were very, very good for the development of our modern society because the properties chemically very stable. They're relatively cheap to make too, so they're very stable, relatively cheap. The boiling point, as it turns out, for these molecules is lower than the boiling point of water, but it was in a range that's good to use as a refrigerant. A refrigerant is a substance that you would put in the coils of a refrigeration unit, and the properties of it that you want is you want something that can be transferred pretty easily from the liquid phase to the gas phase in a cycle. So if you increase the pressure, then you can get it into the gas phase, or excuse me, into the liquid phase. If you decrease the pressure, it's going to go into the gas phase. And when that molecule undergoes that physical change from a liquid to a gas, it absorbs heat energy around it upon that change from the liquid to the gas. And so that's how you get that cooling going on. So it takes electricity, it takes energy to cause that change to occur, but then you can in turn cause the surroundings to become cool. You can remove heat from the surroundings in this cyclical process. So that's why it's a good refrigerant. And also, because this molecule is so stable, it's not toxic. And up to this point in time, when this molecule was introduced in the 1950s and early 60s, the refrigerants that were being used were pretty toxic. And so to have a air conditioning unit or large-scale refrigeration units was pretty expensive and rather dangerous. But with the advent of this very, very stable and safe molecule, the CFCs, then they were able to replace those more toxic chemicals that were used in refrigerators and air conditioning units with this more safe, stable, cheap thing called the CFCs. So what happened then as a result of that for the major economic growth was air conditioning became readily available and very cheap. And because of that, the economy in the South grew. First, cities like Atlanta and Birmingham, Alabama, and some other cities in North Carolina began to increase their economic capacity because people could actually work in factories there. The factories were in the north by and large because it was cooler up there, and in the summer it's just about unbearable in the south if you don't have air conditioning. So it revitalized the economy from the 1960s to the 1970s in Houston and Atlanta, and then later on even Austin and San Antonio were able to attract business, attract manufacturing and other types of jobs that otherwise were not available in the South due to the lack of air conditioning.